Good morning, all. Am I audible? Am I audible?
Yes.
Okay. So in last lecture, we were talking about what is called the large signal analysis of differential amplifier. What is the meaning of large signal analysis? I said you assume that you apply the AC signal which is larger in value and find out what kind of response you get from the system. So we used this particular circuit. So in this case, this voltage is, so if I consider as this point as S, so V in 1 minus, this is VGS1, V in 1 minus VGS1 is equal to what? V into minus VGS2, V into minus VGS2. And from this, you can write it as V in 1 minus V into is equal to VGS1 minus VGS2. And then we substituted VGS1 from the current equation here, and we got this particular equation. So this derivation we have done it last time. So we also written this particular expression in this format, that is square root of mu n cox w by L into ISS or I into V in 1 minus V into square root of 1 minus mu n cox w by L upon 4 ISS into V in 1 minus V into whole square. Agree? We have written this expression for ID1 and ID2, ID1 minus ID2. Right? Why I have written it again? The reason is just I want to show you that what is the condition, what should happen if this circuit should be. So ID1 minus ID2 should be linear function of V in 1 minus V in 2. So what should happen? The square root quantity should not be there. When it is possible? When this one is very, very larger than mu n cox w by L upon 4 ISS into V in 1 minus V in 2 whole square. Right? So under this condition, can I write that 4 ISS upon mu n cox w by L should be very, very greater than V in 1 minus V in 2 whole square. Right? So if I take square root on both sides, it becomes 2 square root of ISS upon mu n cox w by L should be very large in comparison to V in 1 minus V in 2. V in 2, right? What is this quantity? What is this quantity?
V
V overdrive. Under which condition?
ISS by 2 into V1.
The transistor is carrying current equal to ISS by 2. So it is 2 VOV should be very large than V in 1 minus V in 2. And how we represented V in 1 minus V in 2 by VID, right? Input differential voltage. So VID should be very, very less than V in 1 minus V in 2, V over twice. Condition has to be always satisfied in order to amplifier to work correctly. Differential voltage should be very small in comparison to twice the overdrive voltage. If this condition is satisfied, what happens to ID1 minus ID2 will be equal to square root of mu n cox w by L into ISS V in 1 minus V in 2. Right? So this factor will be not there. Right? This is the value. Now suppose if I write this by, so this is, we call it as a delta ID, right? How this can be written? Can you tell me what is this value? what is this value? Mu n COX W by L. So you know the equation for current I by 2 is equal to our ISS by 2. I or ISS, I use this interchangeably, right? Is half mu n COX W by L into VOV square. So from this you can see that mu n COX W by L, mu n COX W by L can be written as, so I write it as ISS, so instead of IS, only ISS, okay? It is ISS divided by VOV square, right? So if I substitute it here, what I will be getting? So square root of mu n COX W by L is ISS divided by VOV square multiplied by ISS into V in 1 minus V in 2. Right, which is equal to, what is this value? ISS divided by VOV square root, if I take it, so it is V in 1 minus V in 2, right? So ID1 minus ID2. How ID1 minus ID2 can be written? Can I write it like this? ID1 minus ISS minus ID1. ID1 plus ID2 is what? ISS, right? So ID2 can be written in this way. So what I will be getting here? ID1 twice ID1 minus ISS is equal to ISS divided by V over drive into V in 1 minus V in 2. I will safely write it as VID. Not an issue. V in 1 minus V in 2 is a VID. Now this is, what is ID1 then? ID1 is equal to ISS by 2 plus ISS by VOV into VID by 2. Agreed?
Yes.
ID1 can be written as ISS by 2 into ISS divided by VOV divided by VID by 2. Okay. Can you tell me, what is ISS by 2? What kind of current it is? What kind of current it is? DC or AC?
DC.
DC. So this is, so even though I have not used the correct notation, it should be ID1. So it is DC current, which is ISS by 2. Why this DC current is flowing in the circuit? Why this DC current is flowing in the circuit? Because of which voltage?
VNCM.
V in CM. VCM is responsible for this current ISS by 2. And plus, there is a current because of differential voltage. Can I call this as the small signal current ID? Can I call this small current as ID?
Yes, sir.
Right? So this is small signal current ID, whose value is ISS divided by V over drive multiplied by VID by 2. Okay, so this is the current that is going to flow through this. So DC current, so this is DC current. I will write it as capital ID. You should understand ID or ID1 or ID2, they are same, plus small ID. Right? So this is the DC plus AC current. And what is the property of a AC current here? It is directly proportional to VID. So the DC current ID is directly proportional to V in 1 minus V in 2, which is good for amplifier, right? In amplifier, the output voltage or the output voltage should be proportional to input voltage. First, what we are doing, we are making the output current proportional to input voltage, and output current can be converted into output voltage by passing it through resistance. So we will be getting, so you can see that. Now suppose instead of what I have done here, in this case, I have replaced this ID1 minus ID2 relationship was there, right? What I replaced here, ID2 by ISS minus ID1. If I do it in reverse way, if I replace ID1 by ISS minus ID2. What equation I will be getting for ID2? What relationship I will be getting for ID2?
ISS by 2 minus ID.
ISS by 2 minus ISS divided by V over drive into VID by 2, right? So you just understand what is the difference between these two equations. Plus ISS by 2 by, ISS by VOV into VID by 2. What is the difference between these two? What is the DC current in both transistors?
ISS by 2.
ISS by 2, same. And what about AC current?
Equal in magnitude.
They are equal in magnitude, opposite in direction. What is the meaning of it? Suppose if this current increases by say 1 microampere, what will happen to this current? It will decrease by 1 microampere. Right? Suppose initially the current with only VCM, current flowing is suppose 0.2 milliampere. Okay, and suppose this, what will happen if it is increasing by, so plus 1 microampere will be here. Here 2.2 milliampere minus 0.1 or 1 microampere, whatever the current. So it will increase in one path by some value. It will decrease by the same amount in the other path. So the total current becomes equal to I or ISS. Okay, you should understand this. Clear? Is it clear what I said? So in differential amplifier, two kinds of current will be present. One is the DC current, which is because of the common mode input voltage, and the second one is AC current, which is because of differential voltage. So in one branch current will increase by some amount, in the other branch it will decrease by the same amount, so that the addition of these two currents, which is flowing through the constant current source ISS, will be always constant. It is not going to change. Clear? Any question? Any question? Okay, so this is what we call it as a large signal model. And what is the condition now? For VID should be less than twice the overdrive voltage. When this happens, your circuit is, so you can see that what is the input voltage we are applying here on one side is VID by 2. So if I draw now circuit, if we draw the circuit like this, this is VDD, RD, RD. Okay, and what we are doing it here, suppose I call this as VG1 and this I call it as a VG2. What will be VG1 consist of? What VG1 consists of? VCM plus VID by 2. What will be this signal?
VCM minus VID by 2.
VCM minus VID by 2. Right? So this voltage will be equal to VCM minus VID by 2. Somebody may say that instead of doing like this, I will apply VID here and this I will connect it to ground. That is also okay. I told you how the distribution take place, how the distribution of voltage take place. Right? So this voltage will be VGS1, this voltage will be VGS2. Okay, so it will be again having AC plus DC values. Okay, now we will see the meaning of small signal analysis. What is the meaning of small signal analysis? VID should be less than twice the overdrive voltage. Under that condition, how to find out output voltage in this case? Now, can you tell me what is the current that is flowing through this? We have just find it out. What is the current that is flowing through this resistance RD? When AC and
ISS by
DC
2
are
plus
present, ISS by 2 plus
ID.
ISS by 2 into
ISS by 2
VID
plus
by V
ID.
overdrive.
Okay. Or I will write ISS by V overdrive into VID by 2. But I will write it as ID. What is the current flowing through this branch?
ISS by 2 minus ID.
ISS by 2 minus ID. Right. So can you tell me what will be the voltage at this point? VOV1. VOV1 will be equal to VDD minus ISS by 2 plus ID into RD. Right? And what is the voltage here? VOV2. VOV2 will be equal to VDD minus ISS by 2 plus ID, sorry, minus ID into RD. If I take the difference, what will happen? If I take V out, what is V out? V out is VO1 minus
2 ID
VO2.
RD.
What it will be?
2 times ID RD.
2 times ID into RD.
So that will be negative, I think.
Negative, okay. 2 times ID into RD, right? So I will be getting the voltage is equal to 2 times ID. But you know that. What is the value of ID? Magnitude wise,
ISS into VID by 2 V
IS
over.
by VOV into VID by 2. Right? So if I substitute in this particular expression, minus 2, ID you said ISS divided by V over
VOV.
into VID by 2. So 2 gets cancelled. So I will be getting it as V out is equal to minus ISS divided by VOV into VID. Right?
Into ID.
Into RD. Okay, RD I have missed it here. Okay, RD. Into RD. Can you tell me what is this? So V out divided by VID is a gain, right? What I am getting minus ISS divided by V overdrive into RD. Okay, what is the expression for say GM? What is GM? What is the expression for GM?
So
So
2
I
ID by V over.
die V overdrive. Now in this configuration, what is the DC current that is flowing through this MOSFET?
ISS by 2.
ISS by 2, right? So it is 2 into ISS by 2 divided by V overdrive because ID is ISS by 2. Remember that small gm and small RO they are decided by DC quantities. So this 2 gets cancelled. So ISS by VOV is nothing but GM. GM into RD is the gain. V out is VO1 minus VO2. VID is V in 1 minus V in 2. Right? So this is the gain that we are getting in case of differential amplifier. So I have shown you with the help of what is called as the small signal analysis. Now the same thing can be done by using the formula. So we are going to see it. Now before moving further, as an exercise, I want you people to find out capital GM from this expression, right, for a current. What is the capital GM value? What is capital GM? What is the definition of capital GM? What is the definition of capital GM? It is
I out by V.
delta ID upon derivative of delta V in. So this V in 1 minus V in 2, I will replace it by delta V in. This is delta V in and ID1, ID2, ID1 minus ID2, I will write it as delta ID. So if you take the derivative of this, remember capital GM or small gm, they are decided by DC quantities. Okay, they are decided by DC quantities. So I have to find out what is the gain of it. What is the capital GM value of it? So you differentiate this particular expression. You will be getting the expression for capital GM. Okay, it is simple. So half mu n COX W by L, mu n COX W by L is a constant. So you can see delta V in, derivative I have to take delta V in will be constant. Derivative of this particular factor will be 1 upon 2 root this complete square root multiplied by minus 2 delta V in plus square root quantity as it is, and then derivative of this has to be taken. So I'm not going to do it, but capital GM can be found out. And in order to find out the maximum value of what is capital GM? Now you tell me what is the difference between capital GM and small gm. Suppose I have a circuit, so I am just drawing a small circuit here. This is V in, and suppose this is a transistor M1, you are taking output from this point. Suppose this is a V out. What is small gm? This is RS, suppose. What is small gm? So this is a MOSFET, this is connected to ground, and this is V in. What is said? How to define GM? Short circuit output current divided by input voltage, right? So this is represented as I out. So I out by V in is nothing but, so for a MOSFET, what is the V in here for this device?
Sir, VGS.
VGS. So this is VGS. So I out by VGS is small gm. So gm is I out by V in, but for this configuration, input voltage is same as VGS. Here you say, is V in is equal to VGS?
No, sir. You have to add the voltage drop across R.
So in this case, I will be calling this as circuit transconductance, capital GM. This is device transconductance. This is called as a device transconductance. This is circuit transconductance. So I out by V in. Now you can see, suppose this is the current I out, right? This is the current I out. If I assume it, this is short circuited. What is the current that is going to flow through RS?
Sir,
What is the current that is flowing through RS?
I out.
I out, right? Now in this case, you can see that, and suppose there is resistance here also RO. So if you solve this, what is VGS here in this case? What is a VGS in this case?
So VN minus RS I out.
Okay, V in minus RS into R out, I out is VGS. So what current it is going to produce? GM into VGS, right? GM into VGS. Out of that, the current that flows through the output terminal, that flows through RS, has to be. So it is RO divided by RO plus RS will be equal to I out, and then you solve it, you will be getting the value of capital GM. So I am writing here capital GM is equal to GM RO divided by RS plus RO plus GM RS RO is the value of capital this one. So in this case also I can find it out by differentiating the equation and equating to 0. Means suppose I have some function. How to find out this maximum value of this function? Suppose one function is given and I have to find out what is the maximum value of this function. When the maximum is going to happen?
So you differentiated and equate to 0.
Yeah, we have to differentiate it, equate it to 0. And the corresponding value, we should put it back into the equation to get the maximum value. So if you solve this particular expression, capital GM is maximum. So I said you differentiate it to get the value of Gm. Again, that equation you differentiate it, equate it to 0. You will get the point at which capital Gm is maximum, and that happens when delta V in is equal to 0. What is the meaning of it? Suppose if I draw it, suppose here if I plot it V in 1 minus V in 2. Okay, V in 1 minus V in 2, and here I am plotting capital Gm. So Gm will be maximum here, and it is going to become here. What is this value? Root 2 VOV minus root 2 VOV plus root 2 VOV. So Gm will be maximum here when delta, this is V in 1 minus V in 2, which is delta Vn will equal to 0. So where you will get maximum gain, where your input differential voltage is very close to 0. So it should be kept as small as possible. Clear? Any question?
Sir, can you show the equation for capital G?
Capital Gm. So I'm just writing equation for ID. I will write delta ID equation directly, and then I will differentiate it. You will understand what I'm saying. Delta ID is equal to half mu n cox w by L into delta V in into square root of 4 ISS upon mu n cox w by L minus delta V in square. So same expression I have written it, same expression which is written here. This same expression I have written it in this format. Okay, so derivative of delta ID with respect to derivative of delta V in, which is capital Gm, half mu n cox w by L. So I am writing it directly now, expression. If you differentiate it, I will be getting it as 4 ISS upon mu n cox w by L minus 2 delta V in square divided by square root of 4 ISS upon mu n cox w by L minus delta V in square. I will be getting it after differentiating this. Now you tell me when this will be maximum? When this will be maximum?
So when 2 delta V in square is equal to 4 ISS mu h.
No, so this will be equal to 0, right?
Yes, sir, when the numerator is 0.
This will be equal to 0, right? When delta V in is equal to 0, I will be getting maximum value of capital Gm. When delta V in is equal to 0, is it correct?
Yes, sir. I thought you meant maximum of ID.
No, maximum of capital Gm. We want gain to be more, right?
Yes.
So when delta V in is equal to 0, it is 1/2 mu n cox w by L. It is 4 ISS upon mu n cox w by L upon square root of 4 ISS upon mu n cox w by L. So what I will be getting finally? What I will be getting capital Gm equal to? What capital Gm I will be getting if I put delta V in equal to 0? Square root of mu n cox w by L into ISS. Right?
Yes, sir. Device transconductance.
Yes, what is the value? Small Gm, right?
Yes, sir.
Small
So it is device
Gm.
transconductance, right?
Yeah, this becomes now device transconductance. So capital Gm, maximum value of gain, so the transconductance that I get. What is the current flowing through the MOSFET? See, small Gm, what is the expression? Square root of twice mu n cox w by L into I, right?
Yes, sir. So current in this case would be ISS by 2.
It is ISS by 2. 2 gets cancelled, so I will be getting this as small gm. Okay, so this is the maximum possible value that I will. Okay, forget about this. For those who are going to do some kind of a lab experiments, for them it is very important. That's why I have covered this particular topic. Now I will come back to what is called as small signal analysis. Okay. Now, can you tell me what is the equation that I got it for ID1? ISS by 2 plus
ISS by V over drive into
ISS by V over drive into VID by 2. Okay. In the original expression, I am not writing, but in the original expression that we got, there was some factor called as, here there was some factor called square root of 1 minus VID by 2 upon V over drive whole square was the term, right?
Yes, sir.
This was the term, right? We have this kind of a term and we said that this should be minimum. So this should be less than 1. Now it is VID by 2 upon V over drive should be very, very smaller than 1. So that VID is very, very smaller than twice overdrive voltage. How to reduce this factor? Can you tell me how this factor can be reduced? How that can be made very smaller than 1? Either you should decrease the value of VID or increase the value of VOV. Right? Either I should reduce the value of VID or increase the value of VOV so that it becomes very small. What is the disadvantage of increasing the value of VOV?
Voltage consumption.
No. VOV, I am.
We get to linear region, right?
Okay. So one is voltage will be, there will be a reduction in the output voltage swing. But what is the other reason?
Transistor will come out
what
of
is GM?
saturation.
No, what is GM? Twice ID divided by V over drive, right? If I increase VOV, what is going to happen?
So gain will go down.
Gain will go down. So these are the trade-offs. Means it is not so simple by simply increasing VOV, I cannot make the circuit linear. Okay. Okay. So with this, now we will see how to do the analysis. So I said, what is the gain? I am getting minus GM into RD, right? So I will draw now circuit and we will solve this circuit by 2 different methods. Okay, so this is I or ISS I will write. This is V in 1, this is V in 2. These techniques are very important in solving the problems. VDD. Now this is RD. I have to find out a gain. So this is V out is the gain, right? So I will call this output as VO1, this output as VO2. Okay. Now you tell me, and what is the input voltage? What is the gain expression? AV is equal to what? VO1 minus VO2 divided by V in 1 minus V in 2 is the gain for the circuit, right? Is it clear? It is called as a differential gain. Okay. Now you tell me how you will find out this gain. What are the different methods available? What are the different methods available? What are the different methods available?
So much large signal and small signal.
Small signal. So I will draw the small signal model of this and I will solve it, which is a very tedious process. The simplest way is to apply the principle of superposition. What is the principle of superposition says? So for simplification purpose, I will neglect first RO. What should be done? I should find out VO1 and VO2. I should find out VO1 and VO2 when only V1 is present, V in 1 is present, by making V into equal to 0. And in the next step, I will make V in 1 equal to 0. And by applying only V into, I will find out what is VO1 and VO2. And then find out what is the addition of these two results. What about ISS? ISS is what? DC or AC current?
DC.
DC.
In calculation of a gain, all the DC sources should be removed. So if it is a DC voltage source, should be short circuited. If it is current source, it should be open circuited. So I open circuited it. Right? Okay. So I will assume that V in 1 is connected to ground. Remember that we are not connecting actually to ground. Somebody will say that if I connect V in 1 to ground, the transistor will be off. We are not making any transistor. We are just assuming that the circuit is connected to ground. Understand that for calculation of gain, all the DC sources should be short circuited. So VDD also is connected to ground. Okay. Now suppose input is applied here and the output voltage is to be applied at the drain of transistor M1. What kind of amplifier configuration it is?
Common source.
Common source amplifier, right? What is the value of resistance that is present in the source of M1?
Sir, the source would be 1 by GM1.
1 by?
GM1.
I should find out what is the resistance looking from this side, right? What is the resistance looking from this side into, because see this is open circuited, ISS is not there. If I look from the source terminal of M2, what is the resistance offered by M2? What is the resistance offered by M2?
1 by GM2.
1 by GM2. Everyone agrees? So what is the equivalent circuit to find out this output voltage? This is RD. This terminal is connected to ground. This is the MOSFET M1, and the resistance between this terminal and ground is 1 by GM2. This is V in 1. This is VO1. This is VO1 because of V in 1. Can you tell me what is the gain? VO1 upon V in 1. VO1 minus V in 1. What will be the gain? Have you got this point? Any question? These are very important concepts in analyzing the circuits.
Sir, one question I had was that why did you shift the resistance, like the transconductance, to 1 by GM1 at the source? We can just...
No. What is the thing is, when you find out, so I'm only finding out the effect of V in 1, right?
Okay, got it, sir. So that is GM2. Okay, got it.
1 by GM2 is the resistance offered by M2 when I look from the source terminal of M2 into the source terminal of M2. 1 by GM2 is the resistance, right?
Yeah, right, sir. Got it.
Okay. So what is the gain here in this case?
Sir, RD upon 1 by GM1 plus 1 by
So it
GM2.
is minus, gain is minus. So I will be writing minus sign. But because it is a common source configuration. What is the resistance connected at the drain terminal?
RD.
RD. Divided by resistance seen through the source terminal. So you open it here and look from here. What is it?
1 by GM1 plus 1 by GM2.
1 by GM1 plus 1 by GM2. Right?
So why are we removing the other RD? Just because it's off?
RD is not. RD, how it will come into picture? Suppose, so that's the question. Suppose I have this configuration and I'm looking from this and RO is neglected here. RO is not there. Is it visible for me, the RD? Is
No,
RD
sir.
visible
I
to me?
wanted to ask for the transistor M2, that RD is removed in the.
So that's what I'm saying now. When I look from, so what I'm saying again, you should understand this. What I'm saying is, suppose this is my configuration. So this is, you are saying M2, right? I'm looking from source terminal of it. What is the resistance? Should I draw the small signal model for M2?
So 1 by GM2 would be the resistance.
Okay, now this is GM2 into VGS2, right? And you are connecting here. So gate terminal is connected to ground for M2. This is plus minus VGS. You are connecting here known voltage source plus minus Vx and finding out what is the current drawn from it. Where is the RD? There is a RD. This is the drain terminal, right? This is RD. Now you tell me what is the value of Ix? What is the value of Ix? Minus GM2 into VGS2, right? And what is VGS2? What is VGS2?
Minus Vx.
Minus Vx is Ix. So what is Vx by Ix? 1 by, is RD coming into picture?
No, sir.
RD is not coming into picture, right? So when I look from, when RO is absent, if RO is present, then something different will happen. Okay, can anybody remember what happens to the impedance if I look from this, if RO is present here? It is RD plus RO divided by 1 plus GMRO. Somebody will say, oh, from where this equation is coming from. Have you done this analysis or not? Have you done this analysis in your course till now?
Yes, sir.
No, sir.
No.
Yes,
When
sir.
you look from the source terminal, if RO is present, it is RD plus RO divided by 1 plus GMRO. When you look from, so, okay, one time I will conduct one kind of a extra, kind of a revision class to understand the different concepts. But if RO is not present, then only 1 by GM. If RO, suppose if I put RO is equal to infinity, what is going to happen? If RO is equal to infinity here,
So 1 by GM.
1 by GM, na? When RO is absent, it is 1 by GM. When RO is present, it is RD plus RO divided by 1 plus GMRO. Okay. So resistance looking from this, so I got this particular expression. What you said about GM1 and GM2, are they same? Are they same? Huh?
Yes, sir.
Yes, sir.
Yeah. So what is the voltage I will be getting? Minus RD divided by 2 by GM. 1 by GM plus 1 by GM. Transconductance, who is deciding? Who will decide small GM? DC or AC current?
So DC current.
DC current. And DC current in both the transistor is same. So it is 2 by GM. So it becomes 2 by GM. So what is the value of this one? Minus GM RD divided by 2 is VO1. VO1 multiplied by V in 1. This is output voltage because of V in 1. Right? Now, what is remaining now in the circuit? What should I do now? What is the output voltage because of V in 1 at VO2? I should find it out, right? I should find out what is the output voltage at VO2 output terminal 2 because of V in 1. What should I do?
Correct VN1 to 0.
Is already equal to 0. But how to find out this voltage now? What should I do? I should find out what is the output voltage here. So this circuit should be replaced by its Thevenin's equivalent. What is Thevenin's equivalent?
So an equivalent circuit consisting of the resistor and voltage source, which
Okay.
represents
Suppose if I consider it something like this. Suppose now circuit is like this. This is V in 1 and I will consider this is V out. Thevenin's equivalent output voltage at this point. This is connected to ground. This is RD. Which is this configuration?
common drain.
Common drain, source follower, right?
Yes, sir.
Okay. Now, see, here I cannot, somebody will say that the gain is directly equal to 1. Okay. Gain equal to 1. But what is the way to do it? I will connect here some dummy resistance. This is the output voltage, I will say. Okay. This I will call it as say RD or RM, I will say. Now, can you tell me what is the gain equation? How the equivalent voltage can be found out here? What is the gain for this? It's a source follower, right? What is the formula for calculating gain? What is V
RS
out?
by RS plus 1 by GM.
What is the resistance connected at the output terminal?
So
What is the resistance connected at the output terminal? What is the resistance connected at the output terminal externally? RM divided by resistance seen through the source terminal. What is the resistance seen through the source terminal? RM output terminal resistance, source terminal. I should open it here and look from this terminal. RM plus
1 by GM1.
1 by GM1 is the output voltage. Is the gain, right? Resistance connected at the output, external resistance connected at the output divided by resistance seen through the source terminal is the formula for all amplifiers. Now you tell me, what is the value of RM actually in the circuit? I opened it here. Open circuit voltage I am finding out. What is the actual value of RM? Infinite, right?
Yes, sir.
Infinite. So if I put it infinite, what is going to happen? RM equal to infinite.
1.
So gain is 1.
Gain will be equal to 1, right? When RM equal to infinite, gain equal to 1. So what is V out? What is V out? V in. And in Thevenin's equivalent, you should find out what is the output impedance also from this terminal. When I open it here, what is the impedance looking from this terminal here in this direction?
So 1 by GM1.
1 by GM1. And what is Thevenin's equivalent circuit? What is the Thevenin's equivalent circuit? Voltage source, output voltage in series with what is Thevenin's equivalent circuit? Suppose if I give you circuit something like this.
Sir, it is the voltage source in series with the total resistance that we see.
Okay, so what should I do now? This should be replaced by, so this complete circuit I should replace it by its Thevenin's equivalent. So I will replace this now by its Thevenin's equivalent here. 1 by GM1 and V in. Thevenin's equivalent voltage is V in, resistance is 1 by GM1. Can I find out again now what kind of configuration it is there now? Can I find out VO2 by V in? Can I find out VO2 by V in now?
Yes, sir.
What is the output voltage? So same formula again. What kind of configuration this one is?
So common gate.
Common gate. So what is the output? So VO2 upon this V in is V in 1. V in 1 is equal to, gain is positive or negative for common gate configuration?
Positive.
Positive.
Okay. What is the resistance connected at the output terminal? What is the resistance connected at the output
RD.
terminal? RD. Divided by resistance in through the source terminal.
So 1 by GM1 plus 1 by GM2.
1 by GM1 plus 1 by GM2. How much is the value? Plus GMRD upon 2. So VO2 is equal to GMRD divided by 2 into V in 1. So you should understand now. So I got VO1 because of V in 1 equal to minus GMRD divided by 2 into V in 1. VO2 because of V in 1 I got it as plus GMRD divided by 2 into V in 1. Agree? Agree?
Yes, sir.
Is it correct? Now, what should I do next? What should I do next now in the same circuit?
So we could find what
Ground
the
V1
effect is for V2, but it will be the mirror image of this.
So first what I have done is, this is V in 1, this is V in 2. This is VDD. This is VO1. This is VO2. This is RD. So I consider this is grounded and find out what is VO1, VO2. Next, what I will do? This is connected to ground and V in 2. Can you tell me what will be VO2 because of V in 2?
So minus GMRD by 2 into VN2.
Minus GMRD by 2 into V in 2. What will be VO1?
Plus GMRD by 2 into V.
Plus GMRD divided by 2 into V in 2. So first what should I do? VO1 minus VO2 because of V in 1. So this minus this. What I will get?
Minus GM.
Minus GMRD.
Minus GMRD into V in 1, right? VO1 minus VO2. I subtracted this. So it is VO1 minus VO2 because of V in 1 is minus GMRD into V in 1. What will be VO1 minus VO2 because of V in 2?
Plus GMRD V into
Plus GMRD into V in 2. What is V in 1? Sorry, VO1 minus VO2 total
so
is
minus GMRD V
Addition of
into
these.
is VO1 minus VO2 because of V in 1 plus VO1 minus VO2 because of V in 2. Okay, so this I got it as minus GMRD into V in 1 and this I got it as plus GMRD into V in 2. Can I write it like this? Minus GM into RD, V in 1 minus V in 2 is VO1 minus VO2, right? What is the gain? VO1 minus VO2 divided by V in 1 minus V in 2. What I am getting here? Minus GM into RD, which is the same relationship that we have derived previously, right? Okay, so you should understand how to proceed about by this method, okay? So, we will stop here. Those who have doubts, they can stay back, other can leave. Any question, you can ask me now. Any
So what will
question?
be the midsem syllabus?
Till whatever we are going to cover, till,
Till the last lecture, right?
yeah.
Okay, sir.
So could you please scroll up to the GM part? I missed out on one thing, the capital GM part.
Hmm. What you want to means which part you're
The other part where you wrote small GM RO by RS plus RO. That one.
no, small GM
RO
upon
by RS plus RO plus small GM.
GM RSRO.
Okay, that's what I missed. Okay.
Okay, so this is for common source amplifier with source degeneration.
Yes.
This is capital GM for common source amplifier with source degeneration.
So will the midsem be open book or closed book?
Closed book it is said, na? I will confirm and I will let you know in the next lecture, okay? Okay?
Yes, sir. Thank you.
Okay. Any question? Any other question?
Sir, could you briefly explain how to find the resistance at the output?
Resistance at the output means you are saying gain.
Yes, sir.
So see these are configurations, something like this. This is a V in, this is RS, this is RD. If I take the output from this terminal, if in absence of RO, in absence of this RO, if RO is neglected, if RO is there, it becomes a very long expression. For common source amplifier with RO, AV is given by minus GM RO RD upon RD plus RS plus RO plus GM RS RO. But without RO, you have to find out what is the resistance connected at the output terminal. Here I am taking the output from drain terminal. So it is RD divided by resistance in through the source terminal. If you look from source, you open it here and look from this terminal. So it is RS plus 1 by GM. And it is common source amplifier, I should put minus sign. Common source amplifier. Now suppose if I take the output from this point instead of this. So resistance connected at the output terminal is RS divided by resistance in through the source terminal. If you look from this terminal, it is RS plus 1 by GM. Understood? And the third configuration is this configuration where input is applied here and output is taken from this point. This is RD, this is RS. This is connected to ground for gain calculation. What is the resistance connected at the output? RD. What is the resistance in through the source terminal? You have to open it here and look from this. It is RS plus 1 by GM. Okay.
Yes, sir. Thank you.
Any other question? Any other question?
Sir, could you go to the part where you derived the current for each branch, like ID1, ID2?
ID1, ID2. Okay.
Yeah, that part. Yes, sir. You had mentioned that you've taken some approximation here, right?
Approximation, what approximation is that square root part has been neglected, right?
Yeah, that one. So could you show the where exactly you neglected that?
So here that this part I have not considered. The square root part has been neglected here. This part.
Okay, got it.
Small single condition.
Right, understood.
Okay. Any other question?
So can you do some questions related to output resistance, maybe sometime in the class?
Okay. I will do it.
One question. Does the formula that gain is equal to negative of resistance in output divided by resistance seen through source? Is that true for every single configuration?
Yeah, minus, but I said sign will depend on the configuration. If it is a common source amplifier, it is minus. Otherwise, it is plus. So it is applicable in all cases provided that RO is neglected.
Right.
If RO comes into picture, then the formula is complicated.
Then we'll have to like draw the model and everything, right?
Draw the model or you can remember it. I generally say that it is not difficult to remember for all the configurations.
Okay.
So for example, if it is I said for common source amplifier, it is minus GM RO RD divided by RD plus RS.
Right.
RD plus RS plus RO plus GM RS RO. For common gate configuration, it is 1 plus GM RO divided by RD plus RS plus RO plus GM RS RO into RD, whole RD. And for source follower, you can apply directly the formula that we have seen. But in case of source follower, the body effect is modeled as resistance between output terminal and ground. There are different reasons for it. I will explain it in some of the lecture. Okay. I will not be doing it in the regular lecture. I will do it in some extra class.
Yes, so could you just take a class where we just discuss like these formulae and the application, like maybe a simple problem, something, because I find it quite hard to like remember all the different configurations.
Okay. So can I do it in this week, sometimes in the evening time?
Yes, sir, that would be great.
Okay. So I will put one extra class where I will explain all this. Huh?
Yeah, thank you so much.
Yeah. Anything else?
No, sir.
Okay then, thank you.
Thank you, sir.
Thank you, sir. Sir?